Alright, let's now complete this microservice. We will add two new classes. First, add Kafka Streams configuration class, which will configure properties to be used in Kafka Streams. It will annotate it with configuration, and then we will inject Kafka Streams config data and Kafka config data. And create a bean to return properties that is qualified with text stream configuration. Here we set a unique application ID which is necessary to set for a Kafka Stream application, and then set bootstrap servers and schema registry server URL to connect to Kafka, then specify default key and value Serda types, and set the state directory configuration which is required to be able to keep a state in Kafka Streams application. We will see how we will use this config shortly. Before creating the implementation of Stream Runner, we will first update the Twitter to Kafka service, which was the first microservice in our architecture, and there we had the logic to create the required topics. So I will just update the configuration of the Twitter to Kafka service and set a second topic to create, because in this Kafka Stream service, we want to persist the data to a new topic with new data. Now we need to define a new Aura schema also and create a new Aura type in Kafka model module for this new Kafka topic. Here is the new AVSC file with fields word count and create stats. And if we run the maven install command now, it will create the Aura module for us. Let's now create the Stream Runner implementation, Kafka Streams Runner, and annotate with components. Then create a log variable and also a constant regex for using to match any non-word character in a text, which we will use to split the input text to obtain word count. Then inject Kafka Streams config data, Kafka config data, and properties for Kafka Streams configuration we defined. Let's now implement the first overwritten method, start. First, we will create a singleton map here for schema registry URL to be used in creation of Serda classes. Then we will create a stream spoiler class, which is the main class to create the Kafka stream. Let's then create the Serda object for the input topic. As mentioned, a Serda class specifies a serialization object. There are predefined types like for string or long, or we can create a custom Serda with a generic type and using the specific Avro Serda class. Here we created a specific Serda for input topic with type Twitter Avro model, which is the model used in the first microservice, Twitter to Kafka service, as you can remember. We need to configure this Serda with the schema registry map we created, and as a second parameter we pass false, which specifies that this type is not a key. Then we use stream spoiler, stream methods, and pass the input topic name, and also pass the key and value Serda types to consume. As you see, for key we use Serda's long, as in the input Kafka topic, we have a long key and Twitter Avro model for the value. I will create a new method for this K-stream creation logic. We will now create the computation logic, which is called topology in Kafka Streams terminology. Let's create a new method called createTopology, and then pass Twitter Avro model K-stream and Serda config as parameter. First, we will create a pattern using constant regex we created, to use it in parsing and splitting the input with non-word characters and create a list of words with the help of pattern split method. We will then create a method, getSerdaAnalyticsModel, to create and return the output model Serda object, which will be a Serda of generic type, Twitter Analytics Avro model. So we will first call flatMap values on Twitter Avro model K-stream object, and then map the input to list of words on the text field. FlatMap takes a function and creates an arbitrary number of value from a single value, where map used to create one-to-one mapping. So here we obtained a list of words in the text field of Twitter Avro model object. Now we will call groupBy method, which will return a group stream, and it can be aggregated with the method count to return a key table that holds words and the count per word. Then we will call toStream and call map to map this stream to new Twitter Analytics model. So in new topic we will use the word as key and Twitter Analytics model as the value. Here we will create a key value and it is created with a key value mapper. So let's extract a method for this part. Here we first log info message and then create a key value object with word as key and a Twitter Analytics Avro model object as value. Finally, with a method, we will send this mapped result to output topic, and this time we will use produced class and use Serda string for key and create a new Serda for Twitter Analytics Avro model as we created for Twitter Avro model. This will do the job to read the data from input topic and insert into the output topic. However, I would like to create a state store also to hold the latest state of the computation and allow it to be queried with a REST API. To do that, I will change the count method and pass a materialize parameter that specifies that running count should be stored in a state store named. The materialize store is always of type bytes and byte array, as this is the format of the innermost store. For the state store name, we use the config variable word count store name. This state store will hold key value pairs for word as key and word count as value. Finally, we will call streamBuilder's build method to get the topology we created and log the topology information using describe methods. Then we create a global Kafka streams variable and assign this by passing the topology and the stream configuration we injected, and call the start method on the Kafka streams object to start the computation. I will extract this part as a method named start streaming. We created this Kafka stream as a global variable because we will also create a predestroy method to safely close the Kafka streams when the application closes. Let's do that in a close method. Alright, we will now implement the second method from streams runner interface, which is getValueByKey. We will create a private volatile key value store variable with type read-only key value store with generic type string and long. And in the method, we will first check if Kafka streams is in running state. If so, we will initialize key value store lazily using double check locking pattern. So first check if key value store is null. We will then synchronize on object this, which is the singleton Kafka streams runner object. Then in the synchronize block, check again if key value store is null. If so, initialize it by calling Kafka streams store method and use the word count store name from config to obtain the queryable key value store created during Kafka streams. After successfully creating key value store, we can use the get method on it to get the value by key. This key value store will return the word count by word. Note that to safely initialize key value store with double check locking, the read-only key value store variable should be defined as volatile, because multiple threads should see the latest updated value of key value store, which is provided with the volatile keyword. As volatile forces to fetch the variable's data from main memory each time for a thread, instead of using CPU caches. We will use this getValueByKey to call it from the REST API we will create. Note that when processing the words, we use toLowerCase method. So when querying a word from key value store, we do the same and use toLowerCase method before getting the word count. So first commit and push config server changes. Let's now run this Kafka stream service. To be able to run it, we at least need to run Kafka cluster, config server, and then run the Twitter to Kafka service. Note that Twitter to Kafka service will create the output topic required for the Kafka stream service. Remember to change the port of key clock to 1991 before running it with Kafka, as in Kafka cluster YAML file we have 8081 reserved for the schema registry. Then run Docker Compose app for key clock and Kafka, and then run config server and finally run Twitter to Kafka service. After that, we can safely run Kafka stream service. We should see the info logs now for the data sending to output topic. We can also check the new Twitter analytics topic with Kafka cat command. Great, in the next section we will create a simple API to query the state store we created with this Kafka stream service, and then call that service from query service to show the aggregated word count result on the web client frontend. Alright, I will see you in the next section.